All right, so now we take a look at lesson 5b of polynomials, and this is applications. So we're going to take what we learned in the last section, or the 5a, where we talked about foiling and the box method, and now we're going to apply it into application problems. Now, first of all, what we need to do is realize that if we want to multiply or distribute, and we're doing this with polynomials, well, let's use some warm-up problems to help set the stage for those specific application problems. So in our warm-up here, I'm going to take number 1, and I have a 4 on the outside here, and I can distribute that 4 into the brackets. Thus, this becomes 4x, 4 times negative 1 is negative 4. And if I have this negative in the middle, I know that it's going to distribute to both the terms in the second bracket, because I know that this is like saying I have a negative 1, and it multiplies to both. So my next two terms out of this, when I FOIL my next bracket, is going to be negative x. And then finally, negative 1 times a negative 5 is positive 5. Now, I can combine like terms here, and I would say I have a 4x and a negative 1x, that equals 3x. And a negative 4 plus 5 is a plus 1. There's our simplified solution. We can't combine any more terms here. Now, if I go to number 2, I see that I have a binomial by binomial being multiplied, and then I'm subtracting away binomial. By order of operations, I always know I want to do multiplication first. So I'm going to use the foiling method, which you could equally use the box method here to solve this. X times x is x squared. X times negative 1 is negative 1x. I expand 3 into both of these, meaning I have negative 3 times x is negative 3x. And then negative 3 times a negative 1 is positive 3. Now I see this negative between, meaning I'm going to subtract away this binomial here. Well, I have to actually reverse the signs of both, just like I did in the previous problem. That negative 1 will distribute through the brackets, making negative 1 times x is negative x. And then negative 1 times negative 6 is positive 6. Now, this becomes where it's really important to distinguish between all the different terms. You can do this in a couple ways. Here's one. If I have my x squared terms, I'm going to single underline them. If I have x terms, I'm going to double underline them. And then finally, if I have a constant, maybe I'll use a squiggle to represent the constants. Visually, I can easily see what degree terms should come together here. I could also represent this by highlighting my x squareds with one color, highlighting my x terms with another, and then finally putting my constants together. That would be another way to visually see this. Now, putting these terms together, I have x squared. I have a negative x minus 3x minus another x is negative 5x. And then finally, I have 3 plus 6. That's equal to 9. All right, going to example 3 here. Same situation, except now I have a binomial by binomial with some coefficient here for the subtracted binomial. So I'm going to start by foiling this. I multiply my first term to the second, or to both terms in the second bracket. That's 2x times x, which is 2x squared. I have 2x times a negative 1, which is negative 2x. I then have to distribute 1 to both the second, and that would be 1 times x is plus 1x. 1 times negative 1 is negative 1. And now I need to go to my second binomial, or the second term here, this negative 3x times 4. I'm going to distribute the negative 3 into the brackets for both terms. This will make sure I have negative 3 times x, which is negative 3x, and then negative 3 times negative 4 is positive 12. Now, we want to use organization techniques just like we've done before. So with the x term, or the x squared more specifically, I'm going to single underline it. My x terms will get a double underline. And then my constant terms, I'm going to do a squiggle. And remember, those could be any type of ways you can represent this pictorially. So you could put squiggles, zigzags, stars, whatever is going to show that these are distinct terms. Now, this is equal to 2x squared. Negative 2x plus 1x is negative 1x minus another 3x, that's negative 4x. And then negative 1 plus 12 is plus 11. Okay, example 4 here. I have numbers on the outside that need to be distributed into a binomial. So I have a coefficient multiplied to the binomial. Both of them have negatives on them, so the signs on the interior will flip. If I distribute my first negative 2 times x, negative 2 times negative 1, Well, that's going to be negative 2x plus 2. And in my second term, or my second binomial, negative 2 times x, negative 2 times negative 3, that's negative 2x plus 6. Now, I can do my underline technique of my x terms get a single underline and my constants maybe get a squiggle. And this is going to be equal to, well, negative 2x minus another 2x is negative 4x. And 2 plus 6 is positive 8. All right, for my next example, 5, I have two binomials. In the case of binomial times binomial minus binomial times binomial, I'm going to FOIL both of these and then subtract them because we know multiplication has to come first. X times x times negative 1, that's going to give me x squared minus 1x. I then have 5x times 5, or plus 5 times a negative 1. This is equal to plus 5x. 5 times a negative 1 is negative 5. Now, I go to my second binomial here. I have to take the negative 1 out front and apply it to everything in the brackets here. Or I could wait and then apply it in the end. What I'm going to do maybe first is do the binomial expansion. So x times x times negative 2. This gives me x squared minus 2x. I'm then going to take the 1 and multiply it to both of these. So I have plus 1x. 1 times a negative 2 is negative 2. But now I left that negative out front that was here originally. I could have distributed it originally and then done the binomial expansion. However, what I'm going to do is I saved it and now I'm going to apply it in for each term here. So my new statement is going to look like the following. Is equal to x squared. I'm going to combine my x's. Negative 1x plus 5x is plus 4x minus 5. And now I'm going to take that negative 1 and distribute it to everything. So this is negative x squared plus 2x minus 1x plus 2. All the signs got reversed. And now I want to organize this. My x squared terms will get a single underline. My x terms will get a double underline. And then my constants are going to get the squiggle, just to be consistent. X squared minus x squared is going to be equal to 0x squareds. 4x plus 2x is 6x, minus 1x is plus 5x. And then finally, negative 5 plus 2 is negative 3. Therefore, my statement is 5x minus 3. All right, one more example before we move into applications or the direct applications. So if I have this, I have two sets of binomial expansions to do. And remember, you could use foiling or the box method, whatever works best for you. So if I FOIL this, I have the negative x times the next two in the brackets there. So this is going to be equal to a negative x times 2x is negative 2x squared. Negative x times negative 1 is plus x. Now I go 3 times both of these. That's going to be plus 6x. 3 times a negative 1 is negative 3. Now, I go to my next brackets here because I have that subtraction symbol in the middle. What I'm going to do in this example, rather than save the coefficient and the negative, I'm going to apply it into our first binomial and then do the binomial expansion. Therefore, this is going to be equal to, I have plus negative 4x. Negative 4 times a negative 5 is positive 20. Now I can do my expansion here. So I'm going to take my negative 4x and multiply it to both the next two terms. This is going to be equal to a positive 4x. I then, actually I need to backpedal this up here. This is going to be negative 4x times x is negative 4x squared. Negative 4x times a negative 1 is positive 4x. 20 times x is equal to 20x. And then finally, 20 times the negative 1 will give me negative 20. All right, now I'm going to go back here and rewrite out my original statement for the right side. Negative 2x squared plus x plus 6x minus 3. All right, now I have to organize all my terms. I'm going to put all together my x terms, which will get a single underline. My x terms are going to get a double underline. And then finally, the constants will get the squiggle here. Putting together my x squared terms, negative 2x squared minus 4x squared, that's equal to negative 6x squared. X plus x is 7x, plus 4x plus 20x. Well, that's 7 plus 4 is 11, plus 20 is going to be plus 31x. And then finally, negative 3 minus a 20 is negative 23. There's your final statement. So let's go into specific applications. These are going to involve binomial times binomial, and maybe a binomial times binomial, subtract another binomial times binomial. Well, in the first example here, they say find the area of the shaded region. So they give us dimensions of length and width for both the inside and the outside, and then we want just the shaded region. So what I'm going to do is I'm going to take the outer length and width, or the one that described the entire square, which is the area is 4x plus 6 times the width of 5x minus 4. Well, we want to subtract away that inside square because we only want the shaded region. So I'm going to subtract away the length, which is 2x plus 4, times 3x minus 2. And so this is the larger square, subtract away the smaller square, or the inside there. And that will leave us with just the shaded region. Well, we've seen this before in the warm-up. It's binomial times binomial minus binomial times binomial. I'm going to save subtracting until the last step here. So if I do my first binomial expansion, well, this is 4x times the second two terms. That's 4x times 5x, which is 20x squared. We have 4x times a negative 4, which is negative 16x. 6 times 5x is plus 30x. 6 times a negative 4 is negative 24. And now I need to do my second binomial expansion. Subtract. I'm going to save the subtraction till later. And I should have put my two arrows here. There we go. I'm going to save my subtraction and do the expansion first. I could take this negative and apply it into the brackets right away. However, I'm going to hold off on that. Keep the subtraction sign and expand. So if I expand, I'm going to do 2x times the next two terms. This is equal to 6x squared. 2x times a negative 2 is negative 4x. I then move on to my next terms. 4 times the next two terms. 4 times 3 is plus 12x. And then finally, 4 times a negative 2 is negative 8. This subtraction out here is like saying I have a negative 1 that's being multiplied to every single term in the brackets. So before I can drop these brackets, I have to flip every sign. This is going to be equal to 20x squared minus 16x plus 30x minus 24. Flipping all the signs, it's going to be minus 6x squared plus 4x minus 12x plus 8. Now I want to put together all the common terms here. So with this one, I have 20x squared, and I have negative 6x squared. Therefore, my total x squareds is equal to 14x squared. If I look at my x terms, I have negative 16 plus a 30. That's equal to 14. I then have 14 plus a 4, which is 18. And then 18 minus a 12 will give me negative 6 here, or positive 6, I should say. So we have a positive 6x. And now I need to add together my constant terms. Negative 24 plus a positive 8. That's going to give me a total of negative 16. There is my simplified expression for the shaded area of this region, or that represents the shaded area. So you could say that A is equal to representing the shaded area. All right, 2, determine the expression for each of the following shaded below. Well, we have the same type of situation for both of these. We need to find the area of the entire square and subtract away the smaller to get the shaded. So for this one, I'm going to say that this is equal to 5x minus 3 times 7x plus 5. We're going to subtract away our smaller square. This is 2x times x plus 1. And now before we do this subtraction, we have to do both expansions. So I have 5x times 7x, 5x times 5. That's equal to 35x squared. 5 times 5 is plus 25x. Now I go negative 3 times the 2. This is going to be negative 3 times 7x, which is negative 21x. Negative 3 times a positive 5 is negative 15. And now before I apply the subtraction, I'm going to do the expansion on the next one. 2x times x, 2x times 1, that's going to give me 2x squared. 2x times 1 is plus 2x. Now, I can apply this subtraction to both terms in the bracket, which flips their signs. This is equal to 35x squared. 25 minus 21 is plus 4x minus 15. Then now I apply that negative to both. It's negative 2x squared. And then the positive 2x changed to a negative 2x. Now what I want to do is put all my x squareds, my x, and my constant terms together. My x terms will get a single underline. My x terms will get the double underline. And then finally the constants will get the squiggle here. Our simplified expression for the area of this shaded region is equal to 35x squared minus 2x squared, which is 33x squared. 4x minus 2x is plus 2x. And then finally I have the constant term on the end of negative 15. There's our area, is a simplified expression. Okay, shifting over to a different shape here. We have now a square with a triangle embedded, and we want the area that represents the shaded piece. So if we want this, well, we're going to have to do the same type of expansion that we've done before, where we take the larger square, which is the 4x minus 3, and multiply it by its length, in this case 8x minus 6. But what are we subtracting here? It's the area of the triangle. And so we're going to need to look at the triangle to figure out how do we get the area of the triangle here? Well, we know any triangle has an area equal to base times height over 2. So right away, if I was to look at this triangle, well, we know that the height of the triangle is actually equal to the width of the larger square, 4x minus 3. But how do we get this base component here? Well, the nice part is they give us that these small sections are equal to x, and the entire strip is equal to 8x minus 6. So in order to get that bottom piece there, what I'm going to have to do is say, well, to get our very base here, I have to take 8x minus 6 and subtract away 2 x values, or subtract away this x component and this x component, which represent that small slice here, in comparison to the whole length here. So if I subtract away the 2x, my simplified expression is 6x minus 6. And so on the bottom here, I can write this as 6x minus 6, and that represents just the base of the triangle here. And now, if I'm subtracting, or if I'm taking the area of the entire square, which is our component written here, and now subtracting the area of the triangle, I need to do base times height divided by 2, or 6x minus 6 times 4x minus 3 all over 2. Okay, this is going to take a bit of a work to expand here. So this is equal to, if I expand my first one, 4x is being multiplied to both in the second brackets. 4x times that 8x is equal to 32x squared. 4x times a negative 6 is negative 24x. Negative 3 times 8x is negative 24x. Negative 3 times the negative 6 is equal to positive 18. And now I have to do the expansion and divide by 2 for the separate one here. So I'm going to throw this all in brackets here. We have 6x times 4x, 6x times negative 3. Well, 6x times 4x is 24x squared. 6x times a negative 3 is negative 18x. Now I need to do negative 6 multiplied by the 4, negative 6 times the negative 3, negative 6 times the 4 is negative 24x, negative 6 times the negative 3 is positive 18, and this is all over 2. And now what do I have to do is I'm going to try and simplify as much as possible. In the first binomial expansion, well, we have 32x squared. Negative 24 minus the 24 is negative 48x plus 18. I'm going to keep the subtraction in the brackets, but now I want to divide everything by 2 in the brackets. 24 over 2 is equal to 12x squared. 18 over 2 is equal to negative 9x. Negative 24 over 2 is equal to negative 12x. And then finally, 18 over 2 is positive 9. So if I take this negative 1 and distribute it all into the brackets and then simplify, this is going to be equal to 32x squared minus 48x plus 18 minus 12x squared. Negative 9x and negative 12x are going to come together to make negative 21x, but we know that sign has to flip, so it's going to be positive 21x. And then finally, we have a negative 1 times a negative 9, or a positive 9 is negative 9. Here's where the organization is very, very important. All my x squared terms are going to have a single underline. X terms with the double underline, squiggle for the constants. I'll redo that last squiggle there. There we go. Okay, my x squareds come together to make 32 minus 12. 32 minus 12 is equal to 20x squared. Negative 48x plus a 21x, well, that's going to be equal to negative 27x. And then 18 minus a 9 is going to be positive 9. So there is our simplified expression for the shaded area of this. So the shaded component of this, subtracting away that triangle, is equal to this expression here.